Hello everyone, my name is Sai and today we're going to learn about equilibrium. Alright, so I'm going to draw a line down the middle of the page. This is just to represent sort of the border between reactants, which we'll have on the left side, and products on the right side. So for any of you that have taken chemistry already and didn't really understand equilibrium, or if you're in chemistry right now and you just learned about equilibrium and it makes absolutely no sense, don't worry, I was like that too. But trust me, after this video, it's gonna get much better. So let's start off by adding some reactants. So instead of using random atoms and molecules, we're gonna say that the reactants are actually people in this case. And just to preserve my artistic self-esteem, let's make circles and call them people. Alright, so the rate at which reactants become products, we'll say is 3 people. And then the rate at which products become reactants, of course we have no products right now, will be 1 person. So what this means is we're going to run this little activity in rounds. So in round 1, 3 people are going to move over here. And since there's no one right here right now, nobody's actually going to move over there. Alright, so let's get started with round 1. So we're going to get out the eraser tool, and I'm going to use the big eraser so we could go a little bit faster. And then let's erase 3 of these people. And awesome. Now let's move those 3 people over here. And remember, when we first started the round, we didn't have any products at all. So that means we don't have to move any products to the reactant side for this reaction. At least right now, in round 1. Alright, so we moved our 3 reactants over to the product side. So round 1 is over. Now let's do round 2. So let's get out the eraser tool. So what we're going to do is we're going to move these 3 guys onto this side, then we'll move one of the products onto the reactant side. Alright, so erase, 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 erase. Almost got it. There we go. Alright, so let's put those 3 guys over here. Wow, I guess, and then we'll move one of the products over to the reactant side. And by the way, this side is the reactants. This is a products. Alright, so eraser tool, and then move one of them. Oh no, I cut one of the guys. Alright, it's fine. So let's move that one guy over here. Alright, perfect. So round 2 is over. Now, round 3 time. So we have to move 3 of the reactants over to the product side. But we only have one guy here, so that means we only have to move this one guy. And then we have to move one of the products over to the reactant side. So let's do that. Let's move this guy over to this side. And actually what I'm going to do is move this guy, which we just moved, just one space down. Perfect. And then a guy which we erased from the product side goes to the reactant side. So now something pretty cool happened. We moved one reactant over to the product side, and then we moved one product over to the reactant side. So that means the rate at which the reaction went forward in this direction is 1, and the rate at which the reaction went backward in this direction is also 1. So by definition, we have reached equilibrium, because equilibrium is accomplished when the rates of forward and backward are equal, not when the numbers are equal. So no matter how many times we move this guy over here, and then move another guy over here, we'll still have 5 on this side and 1 on this side, and the rates will be equal. So if we want to get really crazy, what we could do, we can add a bunch more reactants. So let's add 2 more. So now what we're going to do is exploit something called Le Chatelier's principle. And it sounds really cool, and it is pretty cool. So what we did, we added 2 reactants, right? So we're going to continue this reaction and see what happens. So the rate at which it goes forward is still 3. rate at which it goes forward is 3. So 1, 2, 3. Oops. And then the rate at which it goes backwards is 1. Awesome. Alright, 1. So what we did just now in this first round is we added more reactants. And Le Chatelier's principle says that if we put stress on one side by adding more reactants, then the equilibrium is going to try and make more products to relieve that stress. So we did that because more products were made here. And Le Chatelier's principle also says once that stress is relieved, then we accomplish a new equilibrium. So let's see if that worked out. So if we erase this guy and put him on this side, then we erase this guy and put him on that side, then we have equilibrium, because the rate at which the reaction goes forward is 1, and the rate at which the reaction goes backwards is also 1. So we have accomplished equilibrium. But before, whereas we had 5 on one side and 1 on the reactant side, now we have 7 on this side and 1 on this side. So the amounts really don't matter. It's just about when the rates are equal. So I hope that helped, guys. I mean, equilibrium and Le Chatelier's principle are really, really cool. And it's super useful for chemists. You can do even more stuff. For example, it's not just about adding reactants. You can even put pressure on this side if the atoms are gas molecules or gaseous atoms. And you could do a bunch more stuff. So, see you guys in the next video. Hope that helped. Adios!